Okay, guys, we had so much fun reviewing graphing last time. Let's do it again. Here we go. Oh my gosh, same old, same old. So once again, graphing compound inequalities. We're going to graph both inequalities at the same time. And we're trying to find the set that works for both of them. If it's an and, it's a compound inequality containing and is only true if both inequalities are true. The intersection can be found by graphing each inequality and then determining where the graphs overlap. A union, compound inequality containing the word or, is true if either of the inequalities are true. The union can be found by graphing each inequality. Okay, so once again, here's our or. I'm only going to look at the one on the left. 2x is less than 10. 2 and x are being multiplied. Opposite of multiplication is division. So I divide by 2. 2 is a positive number. I get x is less than 5. Now I'm only going to look at the right. X over 2 is greater than or equal to 3. X over 2 is division. Opposite division is multiplication. So I'm going to multiply both sides by 2. So x is greater than or equal to 6. 5 and 6 are pretty doggone close to each other. So here is, it's an or, so I'm going to go right on the graph. Here is x is less than 6. Here is x is, that's less than 5, oopsie doodles. Here is x is greater than or equal to 6. There's a space in the middle we don't have to worry about. Thank you very much. My daughter just brought me a little diet chocolate vanilla, diet chocolate marshmallow Coke.
No,
she didn't.
Candy cane hot chocolate.
She brought me a candy cane hot chocolate. Woo! Treat, treat, treat. She's been to McCord's. Okay, little interruption there. Sorry. Because it's an or, we don't care that they don't overlap. Our answer is x is less than 5, union with or x is greater than or equal to 6. All right, now this one has the word and. So I'm going to look at x plus 8 is greater than or equal to 9. I got to get rid of that plus 8 by subtracting 8. Algebra, remember, is what did you do? What do you have left over? So after I subtract the 8, I have an x left over. Bring down the sign. 9 minus 8 is 1. Now I'm going to look at x divided by 7 is less than or equal to 1. Again, the opposite of division is multiplication. So I'm going to multiply both sides by 7. Don't have to do any switching because I did not multiply by a negative number. The word is and, so I am going to go above the graph. X is greater than or equal to 1, all that stuff. X is less than or equal to 7, all that stuff. Because it's an and, I want to know where they overlap. They overlap here. I see both orange and blue. Here's just blue. Here's just orange. Orange and blue, orange and blue, orange and blue, orange and blue. Drop it down onto the graph. Drop down the circles. They're both closed. So my answer is trapped between 1 and 7. So we would say that our answer is between 1 and 7. So x is greater than or equal to 1 and less than or equal to 7. But we write it as 1 is less than or equal to x, which is also less than or equal to 7. All right, equations, systems of equations, 2 equations. Remember, we can have more than 2. Solved simultaneously. We should all have that word down, shouldn't we? We're either going to have no solution if they are parallel, one solution if they cross at one point, an infinite number of solutions, it's the same line, just disguised in different equations. Okay, so this first one, 3x plus y equals 6. What's wrong with it? The x is not alone. So we're going to move the 3x by subtracting it. We get y equals negative 3x plus 6. Remember, you cannot put the 6 and the negative 3x together because one has an x and one does not. We're going to graph that one. We're going to start up here at 6. 1, 2, 3, 4, 5, 6. Our slope, whoop, that's supposed to be blue. Goofy. Our slope is negative 3 right 1, negative 3 right 1, negative 3 right 1, negative 3 right 1, negative 3 right 1. These are equations, so they're all nice solid lines. And now I'm going to do the next one in green. X minus y equals 2. Okay, we would pause, but I don't know how to pause. Hi, Adam. You looking for Nikki? Okay, never mind. He's not looking for Nikki. Oh, maybe we just told me she's outside. Okay, Adam, say hi to all my students.
Hi, all of Jackie's students.
There you go. They don't know my name's Jackie, but that's okay.
Sorry.
All right, we're going to get rid of the x by subtracting x on both sides. What do we have left over? Negative 1y equals negative x plus 2. Don't lose that negative. We're going to divide everything by negative 1. So we get y equals, oops, negative over negative is positive 1x and a negative 2. So I start at 0, negative 2. Remember that first point is always on the y-axis. You go up or down, and then my slope is up 1, right 1, up. Woo! Bingo, zingo. There it is. There it is. That would be my husband doing the dishes in the background. And we're going to draw a line. Husband, say hi to everybody.
Hi, everyone.
That's husband. Okay. Gosh, so much excitement at my house. All I'm trying to do is make a video. Good thing I'm not really a star or anything, because this could be take 17. Good thing I don't know how to pause it, or you wouldn't have to hear all this stuff. Where do they overlap? Right here. That point is the point 2, 0. Let's go to the next slide. All right, we've got 2x plus 5y equals negative 10. Got to get the y alone, so we're going to subtract 2x. Remember, algebra is what you do. What do you have left over? We've got a 5y left over on this side. On that side, we've got negative 2x minus 10. Can't put them together because one has an x, one does not. Okay, we got to get rid of the times 5, so we're going to divide everything by 5. So y is negative 2 over 5x. Negative 10 divided by 5 is negative 2. We begin right here at 0, negative 2. We go down 2, right 5. We can't do it again, so we're going to go up to left 5. This is an equation, so I'm just going to draw a nice straight line. That's a horrible line. I hope you guys are better at that than I am. Then we've got 5y minus 4x equals 20. We need to get the y alone, so we're going to add 4x to both sides. So what do I have left over? Oh my gosh, this is getting squishy. 5y equals 4x plus 20. Got to get rid of the times 5. So we're going to divide both sides by 5. So we have y equals 4/5 x plus 4. I'm going to start on my y-intercept right here. 0, 4 is up 4. My slope is up 1, 2, 3, 4, right 1, 2, 3, 4, 5. Down 1, 2, 3, 4, right 1, 2, 3, 4, 5. Oh, bingo, zingo! There it is. So this is my point of intersection right here. It is the point negative 5, 0. That is my solution. All right, we are on slide 7 of 13. We are over halfway done. Systems of inequality. Make sure both equations are in. Oh, that should say both inequalities. That's all right. Slope intercept. This is the third time I've done this, and the first time I've noticed that says equations. Oh well. Graph all inequalities individually but on the same coordinate grid, and you want to shade as you go. And the solution set or region is where the shaded areas cross. So we've got negative 2x plus y is greater than negative 4. We've got to get the y alone. So I'm going to add 2x. Y is greater than 2x minus 4. I'm going to start at 0, negative 4. My slope is up 2, right 1. I'm going to do a whole bunch of up 2, right 1s. And I'm going to do some down 2, left 1s. And then I'm going to stop! In the name of graphing, because I do not know, is it solid? Is it dotted? Woo! Such good music right there. All right, this says y is greater than. It does not say equal to, so that means it is dotted. It also says greater than, so that means I go above. Okay, so I am going to draw a dotted line. Whoa, I missed the dots. All right, and I am going to shade above my line. Then I am going to grab x plus 2y is less than or equal to 12. I'm going to subtract x. I have 2y is less than or equal to negative 1x plus 12. I'm going to divide everything by 2. I get y is less than or equal to negative 1/2 x plus 6. So I go up here to 0, 6 on the y-axis, down 1, right 1, 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 up 1, up left 2. What was I saying all those ones for? Silly, silly, silly. Stop! I got to decide. I've got the or equal to right there, so it is a solid line. I have y is less than is below. So then I have to identify where the two lines overlap, and it is this area in here. Remember, any point in that region is a point in the solution set. Any point on the solid orange line is part of the solution set. Green dotted line is not. All right, let's do another one of these. We've got 3x plus 2y is less than or equal to 8. We're going to subtract 3x. So we have 2y is less than or equal to negative 3x plus 8. And we're going to divide everything by 2. So y is less than or equal to negative 3/2 x plus 4. I'm going to start on the y-axis at 0, 4. My slope is negative, so that's down 3, right 2, down 3, right 2. I'm just going to do a whole bunch of down 3, right 2s and some up 3, left 2s. Stop! I have to look at the sign. Does it have that or equal to? It does. So it is solid. It's also supposed to be straight, but it's not really there. It says y is less than, so less than goes below. All right, then the next one. 6x minus 2y is less than 10. We're going to subtract 6x. Don't lose that negative sign. Negative 2y is less than negative 6x plus 10. I'm going to divide everything by negative 2. What? I divided by a negative number, which means I flip my sign. Negative over negative is positive 3x, and 10 divided by negative 2 is negative 5. So I start on the y-axis at 0, negative 5. My slope is up 3, right 1, up 3, right 1. I hit the other line, do not care. This is an inequality. It's all about shading. Stop! Does it have the or equal to line? It does not. So we are just going to draw a dotted line. It says greater than, so I'm going to go above. And where do they overlap? Right in this area here. Anything on the solid blue line and in the purple area is a solution. Anything on the dotted green line is not. Okay, graphing absolute values. You've read that 3 times, so I'm just going to go past it. You can pause if you want. We're going to set what is inside the absolute value equal to 0 and solve for x. We got x equals 0. Remember, that means we're going to set up our t-chart. Our middle x is 0. Then this means y. Well, that should mean y if I could color over it, but it did not. So I'm going to substitute 0 in for x. The absolute value of 0 is 0, and 0 plus 3 is 3. So 0, 3 is my first point. To get to the next point, I'm going to subtract 2. So I'm going to put negative 2 in place of x. Absolute value of negative 2 is 2, and 2 plus 3 is 5. So I go to negative 2, 5. Then I'm going to get to the next point by adding 2. So I'm going to insert 2 in for x this time. Absolute value of 2 is 2, and 2 plus 3 is 5. So I go right 2, up 5, and there is my beautiful straight absolute value v. Oh, I love that. That is very nice. Secret word, very nice. With a little after it. Try to spell that. All right, last slide. So we have the inside the absolute value is just x. So we're going to set x equal to 0. That means on our t-chart, 0 is going to be our middle x. We're going to substitute it in. 3 times the absolute value of 0. The absolute value of 0 is 0. 3 times 0 is 0. There it is, 0, 0. I'm going to subtract 2. That's how I get to my next x. So this time inside the absolute value, I'm going to put -2. Well, the absolute value of -2 is 2. 3 times 2 is 6. So I go to -2, 1, 2, 3, 4, 5, 6. Wow, that's really far away. To get to the one on the right, I'm going to add 2. 0 plus 2 is 2. So I'm going to substitute 2 in for the absolute value of x. The absolute value of 2 is 2. 3 times 2 is 6. So I'm over here at 2, 6. And I have a very tall, skinny absolute value. Totally missed the points, and you know what happens when you miss the points. Just make the points bigger. Okay, there we go. And that's it, guys. We must be having a test like, I don't know, next time. Hope you're ready. Bye.